In this tutorial, we'll be solving polynomial equations and learning how to solve them by graphing and factoring. So the way you would solve by graphing is, for example, let's say you have the dimensions in inches of a portable kennel, and it can be expressed as the dimensions of x width, an x plus 7 expression for length, and an x minus 1 expression for height. Now you want the volume of this kennel to be 5.9 cubic feet. And you want to find the portable kennel's dimensions. Now, the fact that it says the word volume means you're going to have to find the equation for the volume. And a volume equation is length times width times height. So, we know that the length is x plus 7, we know that the width is x, and we know that the height is x minus 1. And we want those dimensions, the volume of those dimensions, to equal 5.9. And the easiest way to do this is actually by graphing. So if you were to pull up your graphing calculator, if you were to pull up your graphing calculator and you were to type the dimensions of the volume into y of 1, and then you typed in what the volume needed to equal into y of 2 and hit graph, then this is what it would show. Everywhere the blue graph, which is the dimensions of the volume, crosses the red line, that is the possibility of dimensions for your x value to be equal to make the volume 5.9. Now, 2 of these dimensions are not possible in the real world. If you notice, 2 of these dimensions are actually negative numbers. Here and here, the x value is negative, which means we know that in the real world, that is not possible. So therefore, we know that the only possible answer is going to be this intersection right here. So if you go to second trace, and we want to know the intersection of these 2 graphs, toggle over, too far, to where it is close to that intersection and hit enter. And then I'm going to hit enter one more time. And then hit enter one more time. And that is the intersection. So when x equals 1.47, y is equal to 5.9. So at 1.47 inches in this case, then you will get a volume of 5.9. So if x is 1.47, that means the width is equal to x, which is 1.47 inches. That means the length is equal to x plus 7, which means it is equal to 8.47 inches. And the height is equal to x minus 1, which is going to be 0.47 inches. So therefore, our dimensions of the portable kennel must be 1.47 by 8.47 by 0.47 inches. Now, in order to solve polynomials by factoring, there's actually 3 different ways that you can use special factoring. The first example we have discussed in the past, where it's a difference of 2 squares. So anytime you have something that is a perfect square minus or subtracted by something that is also a perfect square, then you can place them into 2 parentheses with opposite signs. Now, there is something new called the sum of 2 cubes. So if you have 2 variables or numbers that are perfect cubes, then you also can place them according to this formula. And then the difference of cubes, same thing. So for example, a difference of 2 squares could be x squared minus y squared. You could place this, you could factor this into 2 different parentheses. Or 9x squared minus 49y squared. These are perfect squares. 9x squared would be 3x squared. That makes it the perfect square. And then the perfect square to get this would be 7y. And that is how you would place them into the parentheses. The sum of cubes would look something like x cubed plus 8. And the reason is because x could be cubed, and 8 is actually a perfect cube. It is 2 cubed, because 2 to the 3rd power is 8. Another example would be 27x cubed plus 1. So what cubed will get you the 27x cubed? And the answer is 3x, because 3 cubed is 27. And then what cubed will get you 1? And the answer is 1. Difference of two cubes would be something like maybe x cubed minus y cubed, or x cubed minus 125z cubed. Because again, you can create perfect cubes. So what cube gives you 125? And it is 5. So if you can figure out the number that will get you the perfect cube, you would then be able to place your variables into the formula. So let's actually do an example. So let's say we need to factor 27x cubed plus 64. So the first step that we need to do is we have got to figure out what is being cubed to get you 27x cubed. So in this case, it would be 3x. Again, why? Because 3 to the third power is 27. And then what number to the third power gets you 64? And the answer is 4, because 4 times 4 times 4 gives you 64. So because this has the plus sign, we are going to use the formula a plus b times a squared minus ab plus b squared. Now, to figure out what a should be and what b should be, we're going to go back to this part. So we know that a is 3x, and we know that b is 4. A is not 27x cubed. A is the number that was created to be cubed. So a represents 3x, b represents 4, and now we're just going to plug it in. So a plus b, so a plus b, and then a squared. A squared is going to be 9x squared. Why 9? Because 3 squared gives you 9. And then you're going to subtract a times b, and then plus b squared. I guess you could do that. It might be easier to say a squared minus ab plus b squared. And now we can simplify. 3x squared, we just talked about, was 9x squared. 3 times 4 is 12x, and then 4 squared is 16. And that would be how you would factor this to the sum of these two cubes. Same thing, we're going to factor this. So the first step is we have got to figure out what cubed gets me 8x cubed. And the answer is 2x, because 2 to the third power is 8, and then x to the third power is x cubed. And then obviously this second one is y. Now, because this is a subtraction, we are going to use the formula a minus b times a squared plus ab plus b squared. So we know that a represents 2x and b represents y. So we're just going to plug those in. So a minus b, and then a squared plus ab plus b squared. And now that I've plugged in a and b and then b, I can now simplify. So I'll be left with 2x minus y. The 2x squared is going to give me a 4x squared. Please remember, the 2 also needs to be squared, not just the x, but the 2 as well. And then 2x times y is just 2xy, or no, not 2yx, 2xy. 2xy, it actually doesn't matter the order that you do it in. And then y squared is just y squared. And that is your answer. Now, solving cubes. In this case, when we solve cubes, we are first going to do what we just talked about. In the past, where we had like x squared minus 125 equals 0, we added 25 to both sides, and then we took the square root. You cannot do that in this case, because there's going to be more than one answer. You don't get just a plus or minus like you do with an x squared. With an x cubed, it is different. You will have to use the solving cubes by the special factors. So we are first going to figure out what cubed gives you each of these, and it's going to be a 5, because 5 cubed is 125. Now we're going to place them in order. So we know that this is subtraction, so we're going to use the a minus b and then the a squared plus ab plus b squared. Now, so a is x, and I'll put it over here. A is x and b is 5. So we'll get x minus 5, and then we'll get x squared plus 5x, or x times 5, it doesn't matter, plus 5 squared, which is 25, equal to 0. Now we have two parentheses. And since we have two parentheses equal to 0, we can actually set them both equal to 0. So we can set x minus 5 equal to 0, and we can set x squared plus 5x plus 25 equal to 0. So in this case, we know that x equals 5. But in this case, you're going to have to use the quadratic formula because you cannot use two parentheses in this case to figure out what this answer should be. So this is where we do the negative b plus or minus square root formula. So it would be negative b plus or minus the square root of b squared, which is 25, minus 4ac all over 2 times a. So we'll get negative 5 plus or minus the square root of 25 minus 100 all over 2. So we'll get negative 5 plus or minus the square root of negative 75 over 2. Now, in this case, the square root of 75 can actually be broken down. This is going to be 25 times the square root of 3. And there's a negative, which means there's going to be an I. So we know it's going to be negative 5 plus or minus. The square root of 25 is 5. So we'll have 5i. Why an I? Because there was a negative in the square root. And then the square root of 3. And then all of that is divided by 2. So that are two of my answers, and that is my third answer to make up solving this equation. Now, you also can factor quartics. Now, remember, a quartic is the degree that is raised to the 4th power. So, for an example, let's go back to quadratics. We know how to factor quadratics into what multiplies to give you negative 6 and adds to give you negative 5. And the answer is negative 6 and 1. So we would factor that as x minus 6 and x plus 1. In this case, you actually can do the same thing. So if you think of this as what squared minus 5 what minus 6, again, you have something squared minus 5 times a variable minus 6. So if we do the same thing and create a new variable, it would be x squared, which got you x to the 4th, minus 5x squared minus 6. And the reason I'm doing that is because, again, if we take a variable, and basically we could call it u, so u squared minus 5u minus 6 is just 2 parentheses. So instead, it's just going to be, instead of it being a u squared minus 5u minus 6, it's going to be an x squared minus 5x squared minus 6. And now again, you can do the big X. And so your answer is going to be, instead of it being x minus 6 and x plus 1, it is going to be x squared minus 6 and x squared plus 1. So now let's try this one. Now, if you think of this again in terms of what we have seen in the past, which is x squared minus 13x plus 36. And if we do the big X, what multiplies to give you 36 but adds to give you negative 13? And the answer is negative 9 and negative 4. So we know that the two parentheses are going to be negative 9 and negative 4. Normally, it's just x minus 9, x minus 4. However, these are in terms of x squared. Again, you can rewrite this as x squared as your variable instead of x. And so it would be x squared minus 9 and x squared minus 4. Now, normally, just like down here, we would be done. However, this is actually also a perfect square. X squared minus 9 can actually break down into x plus 3, x minus 3. And then x squared minus 4 happens to also break down into x minus 2, x plus 2, because it is a difference of perfect squares. So this is actually how you would factor that. Same thing here. If you think of this as a difference of squares, what squared minus what squared, in order to get you that, it would be x squared, and it would be 10. So in the past where you have the same parentheses, except one is minus, one is positive, normally you would have x minus 10 and x plus 10. But because that is an x to the fourth, that means this becomes an x squared. Now, neither of these will factor any further, so that means you are done. So now that we have factored cortex, now we can solve cortex. So let's think of this again in terms of x squared minus 10x plus 9. If we were to do that, we would do the big X, what multiplies to give you 9 and adds to give you negative 10. And the answer is negative 9 and negative 1. So we would have minus 9 and minus 1. But instead of it being just x minus 9 and x minus 1, because this is an x to the fourth and x squared, it would be x squared minus 9 and x squared minus 1. So now to solve these, you would now set them both equal to 0. And then solve. To solve this, you would just add 9 to both sides. And then you would take the square root of 9, which will give you a plus and a minus 3. Please be very, very careful. Make sure that you put the plus and minus when you're taking the square root, because 3 squared will get you 9, but a negative 3 squared also will work backwards to get you 9. Now in this next case, you would just add 1 to both sides and get x squared equals 1. And so then you would take the square root of both sides, and you would get x equals plus or minus 1 as well. Don't forget, make sure you put plus or minus of both sides. Next, so to solve for this, we first need to put it in terms of what we are used to seeing. So big X, what multiplies to give me negative 12 and adds to give me 4, and it is a 6 and negative 2. So instead of it being plus 6 and minus 2 for x's, this is dealing with x to the fourth, which means our term is x squared that is going to go inside the parentheses. And now we are going to solve these by setting them equal to 0. So in this case, we would subtract 6, and then we would take the square root of both sides. So we would get plus or minus I square root of 6. I, because there was a negative in the square root. In this next case, we would add 2 to both sides, and then we would take the square root again, and we would get plus or minus the square root of 2. No I, because there was not a negative square root. So it's just these, there's no negative inside the square root.